Hi guys, welcome back to the next video in the series of videos about Chapter 5, Forces and Motion. Last time we talked about the resultant force, and we saw that a resultant force is needed to change the speed of an object. If you've not yet seen that video, I suggest you do that now, and you can use the link that pops up now. In today's video we will see why you need a resultant force to change the speed of an object, and it has to do with something called inertia. As always, let's review today's learning goals. After this lesson, you will be able to explain what inertia is, explain Newton's first two laws of motion, and either calculate the resultant force or the acceleration using Newton's second law. But let's start with the concept of inertia. Let's have a look at what inertia does before I explain what it is. Here you see a very happy dog and a cute little baby. Did you see that? Did you see what happened when the dog started running? Poor kid. Let's have a look again. Oh. Here's another example. Okay, wait for it. Did you get that? Did you see what happened to the books? So we've seen what inertia does, but what is inertia? Inertia is the resistance objects have to change their speed. That means that a moving object will keep on moving in a straight line and at a constant speed unless there is a resultant force acting on the object. And an object that is at rest will remain at rest when there's no resultant force acting on that object. This is known as Newton's first law of motion. It tells us that a resultant force is needed to change the speed of an object, but it does not tell us how much the speed changes. And that's where Newton's second law of motion comes in. Okay, so don't try this at home, but imagine kicking this bowling ball with all you've got. Well, besides you getting hurt, the bowling ball would probably not move very far. In other words, its state of motion will not change much. The bowling ball will not accelerate much. Now, imagine kicking this soccer ball with the same amount of force. It will move a much farther distance than the bowling ball. The state of motion of the soccer ball will change a lot. The acceleration of the soccer ball will also be larger than the acceleration of the bowling ball. But what is the main difference between the bowling ball and the soccer ball? That's right, their masses are different. So we're looking for a relationship between force, acceleration, and mass. And this relationship is known as Newton's second law of motion. According to Newton's second law of motion, the resultant force is equal to the mass times the acceleration of an object. In this worked example, we're going to calculate the acceleration using Newton's second law. A car and a motorcycle are waiting for the traffic light to turn green. The mass of the car is 1,000 kilograms, while the motorcycle's mass is only 250 kilograms. As soon as the traffic light turns green, both the car and the motorcycle accelerate. The resultant force acting on both vehicles is 2 kilonewtons, or 2,000 newtons. We can rewrite Newton's second law as follows. The acceleration of the car is equal to the resultant force divided by the mass of the car. And that becomes 2,000 divided by 1,000, and the answer is 2.0 meters per second squared. Now let's do the same thing, but now for the motorcycle. Since the motorcycle mass is smaller than the mass of the car, that means the motorcycle acceleration will be different. In this case, we have to divide 2,000 by 250, which is the mass of the motorcycle. And the acceleration of the motorcycle is 8 meters per second squared. Now all the motorcyclist has to do is avoid the car. Let's have a look at another example. In this example, we're going to combine Newton's second law of motion with the formula for acceleration you learned in the previous video. Formula 1 cars are known to have great acceleration, and some of them have been recorded to reach 72 kilometers per hour as fast as 2 seconds. Let's work out the acceleration first and the resultant force second. A typical Formula 1 car has a mass of 605 kilograms. Remember, we have to convert the speed to meters per second first. And that means that in this case the acceleration becomes 10 meters per second squared. Now that we know what the acceleration is, we can finally calculate the resultant force. The resultant force is equal to the mass times the acceleration, which in this case is 605 times 10, resulting in 6,050 newtons. And that's it. Concluding. Now you know how to explain what we mean by inertia. You can explain Newton's first and second laws of motion, and you can calculate the resultant force or the acceleration using Newton's second law of motion. And that brings us to the end of this video. In the final video, we will have a look at braking and collisions. Until next time.